Okay, this is lesson 4.2, unit 4, lesson 2, the particle nature of light. We have the quantum concept. When objects are heated, they emit glowing light. An example I discussed in class was that when a piece of iron, which is typically kind of grayish or reddish, is heated up, it turns red, and then orange when it gets hotter, and then blue when it gets even hotter. Those colors are on the color spectrum, Roy G. Biv, and every one of those colors has a frequency. So the cool thing with this is that we can determine what an element is based on the color it gives off. I gave you guys a picture of different fireworks yesterday and how all the different colors, green, red, orange, blue, silver, white, they're all made of different types of elements. And whenever the electrons within those atoms is heated up, the electrons get excited. But then when they kind of cool down and release their energy, that is light. And we can see that that is atomic emission, which we're going to get to later today. Max Planck discovered matter can gain and lose energy, but in small steps, one at a time, that are called quantum or quanta. You can go up one energy level at a time, 1 to 2, 2 to 3, 3 to 4, or you could go down 4 to 3, 3 to 2, 2 to 1. You cannot skip steps. You can't go from 1 to 4, and you can't take half steps. You can't do 1.5, 2, 2.5. It's got to be 1 to 2, 2 to 3, 3 to 4, and so on. Planck also proposed that energy emitted by hot objects was quantized. It had different levels of energy, like the iron. You have energy level red, then energy level orange, then energy level blue. He came up with a mathematical equation, which is where we left off yesterday, and it is E equals HV. And with this new formula, you guys have a constant that you're going to have to memorize. We have E equals H nu, not V, nu. And by the way, guys, whenever you're writing V, do that. Here's what I do. When you're writing nu, like for frequency, I do this. Shoot. Let's try again. I do that. Again, watch. Down, then up. Down, then up. Here's a V. See the difference? So this is the Greek letter nu. That means frequency. You got E's measured in joules. You haven't gotten joules yet, but I'll teach that to you today. And then you have Planck's constant. 6.626 times 10 to the negative 34 joules per second. And that's where we finished yesterday. Whenever you see that dot, which means multiplication, you say the same thing I told you when you see this little line right here, which means division. You say per. Like if you had miles per hour, you see that division line, you say per. But if you also had this, you would also say per, okay? Let me be sure you all were aware of that. So I have a sample problem for you that we're going to do momentarily. But first I want to tell you about joules and Planck's constant. So this is where all of you here in class should pick up wherever we left off. Planck's constant is 6.626 times 10 to the negative 34 joules per second. Whenever you are doing any sort of math equation, you don't have to find H. One of you, and I'm not going to say who you are because I don't want you to hesitate. Text me when you have an issue. One of you texted me the other day when you're doing your radio station homework, how do I find C? And I responded to you. I said, C is a constant. It doesn't change. You don't have to, quote, find it. It's always given you. C is always 3.00 times 10 to the 8 meters per second. Planck's constant will never change, so you don't have to find it. Now, this unit of measurement right here is joules. It is the SI, or metric unit, or energy. You will see joules a lot in the second semester. In fact, the final unit of this entire course, when school year is almost over, is thermochemistry. A lot of energy, a lot of joules. Now, the relationship that joules has with frequency is the same. So as energy increases, frequency increases. So the words energy and frequency can be interchangeable. The frequency of gamma rays is very powerful. So gamma rays have a lot of energy. Radio waves have very low frequency, so they have very low energy. Yes.
Metric is like centimeters.
That's right. Yeah. Imperial, boy, that's a good question. What is, I'm not sure. I don't think it's amps. That's a good question. You got me. I had to find that out. Let's see. Let me Google it right now. The question was, if joules is metric, then what's the imperial version of that? Let's find out. I knew that. Calories. Kilocalories, technically. Duh. I'm sick. I blame that for having the cold. I don't feel well. All right. Let's continue. Let's go to the photoelectric effect. Now, in my bio classes, my AP college level bio classes, we're learning all about photosynthesis right now. So I've been saying photo a lot. I want you guys to know what I told them. Photo is Latin for light. Some people are photosensitive. You have photoreceptors in your eyes. Plants perform photosynthesis. Plants are called photoautotrophs. Photo means light. They need light. So just want to get that across. The photoelectric effect is when electrons, and what is the charge of electrons, by the way? All right. Electrons are emitted from a metal's surface when light of a certain frequency shines on the surface. So I'm going to give you a little example. This is a metal. Doesn't matter what. And throughout this metal, there are electrons in its atoms. I'm going to draw these really big electrons. Okay? And then here's light. According to the definition of the photoelectric effect, when this light shines down on the metal, some electrons escape. And those electrons give off a frequency. My voice is, I am sick. So my voice might crack a lot, Alex. You're not, Nella, look, you listen. When a guy goes through a cracky voice, you're supposed to pretend like it never happened. Right, Aiden? You don't know, we don't know when it's going to happen, do we? It's a sneak attack. And girls are supposed to pretend like it never happened. So if Aiden or someone is asking someone out to the prom, he goes, "Hi, would you like to go to the prom with me?" Girl can't go, "Not cool, girls. Not cool. Don't do it." This will look great on the YouTube for when people are absent. All right. Anyway, back to this. We have fun conversation in here. These electrons will emit light. And I want to tell you what the point of this, why am I telling you this? What is the point? How do we measure light? What are two characteristics of light? You learned this on Tuesday. What? No, that's what they're made of. We're not there yet. What are two characteristics of light? Think of the electromagnetic spectrum. You did it from what? The color. You're on the right track. The color, every color has a unique blank and blank. What? Frequency is one. Wavelength is the other. Whenever light shines down on metal, they emit light. And this light has a unique frequency and wavelength. Here's why I'm telling you this. We can determine what the metal is based on the color it gives off. Guys, we do this with stars and planets throughout space. No human has ever stepped foot on another planet before, ever. We've barely made it to the moon so far. So we see stars way out in space. We see planets way out in space, and they give off light. We can determine what those stars are made of and what is in those planets' atmospheres based on the light that they give off, because every element gives off a very unique frequency and wavelength. So if we were to look at Venus, our closest planet, we could determine what is in the atmosphere of Venus by the light that it gives off. Every form of light is radiation, and every form of radiation is very unique wavelength and frequency, and every element gives off a unique wavelength and frequency. Yeah. Not that we're aware of, but we think there used to be. We're trying to find evidence of it, because if there was water, there could have been life. All right. Let's go on. That was the photoelectric effect. When you shine light on metal, electrons come off. Those electrons form light. And you can determine what the metal was based on the frequency of that light. Say light. Don't lie. Don't lie. Don't do it. Don't lie. I'm sick. All right. You know, you could have had a sub and then we'd be way behind, but here I am sucking it up. So that's when you're supposed to say, thank you, Mr. Thorson. You're welcome, Nick. All right. I knew that you would miss me. All right. Let's go on. Light's dual nature. In 1905, well, more than 100 years ago. Here's a name I'm sure you've heard before. I totally misspelled it. Albert Einstein. What country was he from? Proposed that light has a dual. How many is dual? Has a dual nature. He suggested light has wave, like, and particle like properties. Now, let's see how well you guys have been paying attention, because I know this stuff is new, and new stuff is confusing. If light has wave-like properties, how would you measure those? What do we measure waves as? Like what do, look at me, this or wavelength and frequency. We measure them with wavelength and frequency. Wavelength is going to be in meters. Frequency can be measured in hertz. And then they have particle light. Now, Aiden, you said this a moment ago. Light is actually made of particles. That's what Albert Einstein actually proved. It's not just energy. We all know about solar energy. You have a big old solar panel, you can collect energy and make electricity to keep the lights on. But it is also made of particles. What are those particles made of? Photons. Photons are massless, they have no mass, particles that carry quantum of energy. So I'm actually going to show you guys something that I taught my AP class to maybe kind of, sort of help you make this make sense. That was a long walk, but I'm going to try to show you this, okay? So what I'm going to do, after you're done writing this, I'm going to flip over to my AP classes. I want to show you something I just did with them Tuesday. My AP bio class, all right? We're doing photosynthesis right now. What does the photo and photosynthesis mean? Yeah, we all know plants need light. So let's see. Let me go to my second period. Let's do this. Let's go right here. Okay. Move that. I want you to see this. I just want you to focus in on this, okay? Focus on that. I'm going to get up for a sec. I'm going to talk loud so the computer can hear me. All right. This orange box is a protein found inside the chloroplast of a plant cell. It is called photosystem 2. When you hear photo, what should you think of? Light. What did I draw above photosystem 2? Sun. And what is the sun shining down on the photosystem? It's light, right? Well, what is, you all know this, I mean, come on, you're in chemistry. What is H2O? Water. Good, that's water. Now, water is something that plants need. But when enough energy, this is where Einstein was coming in. When enough energy is provided to the photosystem, water can be broken apart into three things. It gets broken up into oxygen, hydrogen, and electrons. The oxygen that all of you inhale with every breath comes from water. Plants put it there. Every breath you take in came from water, and plants were able to make that change. What I want to focus on is this. This is an electron. And if you ever took AP Bio, you will learn this. You don't have to know this. I'm just giving you a real world example of how this works. These electrons from water go into the photosystem. And the energy of the sun, the photons, energize the electrons to become excited. So the electrons were down here, low energy. Now they're way up here, high energy. The only reason they got from low to high was because of the solar power. Now, as you go further through this process of photosynthesis, the same thing happens. Where are you? Right here. I told you all this yesterday. One of you has to remember. What do you call the state an electron is in when it really has no power? It's in the ground state. And what do the photons from the sun do to the energy in that electron? It made it excited. There's the ground state and there's the excited state. This is why, by the way, I do not allow any of my AP Bio students who haven't taken chemistry, like all of you are now, be in AP Bio. I have 154 students, I think, 154 AP Bio students. I look at each and every one of their report cards during high school. And if I find out any of them did not take chem, they can't be in that class. Because imagine being in AP Bio and you've never heard of what an electron is. That stuff does come up. So they're totally fine with it. And this is where, if any of you do want to take AP Bio, you do have to know a few things from chem in order to take that class. So little notice to be sure you're always paying attention. All right, so back to this. The energy from the sun actually powers up electrons and makes them go up quantum from 1 to 2, 2 to 3, 3 to 4, get more and more and more energized. So there's particles in light and there's frequencies and wavelengths in light. That was all thanks to Albert Einstein. And he has another equation, looks awfully familiar to what Planck had. The energy of a photon equals Planck's constant times frequency. This is energy. What is energy measured in? Joules. This is Planck's constant. And this is frequency. Frequency can be measured in hertz or waves per second or the reciprocal of a second. So I have a practice problem for you all that you can do in your notes. I want you all to please have a calculator out. You want to do practice now so you're ready for your test, which is the first day of the second quarter. Your test will go into the second quarter grade. It's a heck of a way to start out the quarter with the test grade. All right, so I'm going to show you this practice problem. Where did I put it? There it is. Let's bring it over here. Can I move it? I'll just zoom in. Here. Give you a chance to try to solve this. Every object gets its color by reflecting in any portion of incident light. The color is determined by a wavelength of the reflected photons, thus by their energy. What is the energy of a photon from the violet portion of the sun's light if it has a frequency of 7.230 times 10 to the 14th reciprocal seconds? I will help you get started with this, okay? So you're going to use Einstein's equation, but before you do that, you guys have to be able to just read. What is the energy? Stop right there. What are you solving in this problem? Are you solving for E, or are you solving for H, or are you solving for nu, frequency? Yes, you're solving for this. What are you given in the problem? You're given a frequency of 7.230 times 10 to the 14th reciprocal seconds. So is that number right there, is that H or is that nu? That's this. And aren't you already given the constant? Yeah, it should be a given. So I'm going to give you guys just a couple minutes for those of you that really know what you're doing. If you don't know what you're doing, just stand by. I feel your pain. We'll go through this. I want to help you understand how to do this kind of stuff on your own. There is a lot of math and chem. I want to try to just baby steps before I really let you go flying on your own. So I want to give you about a minute to solve for this. I need the energy measured in joules. See if you can find it. This is basic algebra. You don't need to rearrange anything, so you're just basically doing multiplication. The problem is already set up for how you want it to be. See if you can do it. I'll give you about 90 seconds. That's a minute and a half. If you're sitting at home, just stand by. Oop, power's almost out. About 30 seconds. All right. Now, before I even get started, your ability to read and comprehend is the most important thing with this class, not your math skills, not your ability to pay attention, reading. You have to be able to determine what you are given and what you are not given in every word problem. I call them knowns and unknowns. So let's take a look at your knowns. Well, you only have three variables to choose from. What is the energy of a photon from the violet portion of the sun's light if it has a frequency, there's the known, 7.230 times 10 to the 14th reciprocal seconds. That is your value for nu. That's frequency. The other value that you are given is Planck's constant. It's not in the word problem because it's a constant. 6.626 times 10 to the negative 34th joules per second. That's H. Your unknown is energy. You don't know. In fact, it says, what is the energy? That's a question. So do you have to rearrange this formula at all to find the answer? No, it's already set up for you. You don't need to do any divide both sides by this and that. It's already good. So E equals H nu will now be E equals 6.626 times 10 to the 34th joules per second times 7.230 times 10 to the 14th, 10 to the negative 34, almost left that out, reciprocal seconds. Now, here's going to be one of the little things that can either doom you or gift you an answer. One of those little, this is one of the little tiny things. I want you to switch reciprocal seconds to waves per second because you want seconds to cancel out. They will cancel out. And your answer will be measured in joules because you're trying to find energy, right? So this is where you get your calculator out, guys. I want your feedback. Tristan, you're my victim. I mean, volunteer. Tristan, what is 6.626 times 7.230? Thank you. Now, you all should have learned this in Unit 1. When you were multiplying two numbers that are in scientific notation, you multiply the coefficients. So what Tristan did is he did 6.626 times 7.230. Tristan, do you remember what you do with the numbers that are on the exponents for the notation? When you're multiplying, you add them. So Tristan, what is negative 34 plus 14? Negative 20. Good. And what units of measurement canceled out? Seconds. So what's left? Joules. So there's E. But, Chem kids, if you submitted your answer like this, I want to warn you all of something. There's two ways I could say, yeah, but. I want you to avoid me having the opportunity to come to you and go, you got the answer, yeah, but there's something you could have done better. Here's one. You guys, 95% of the time, cannot have a naked number. What do I mean? You have to put the unit of measurement. So all of you, Garrett, I'm warning you right now. If you just write your answer like that, I will give you half credit. It's not 47.9 times 10 to the negative 20. It's 47.9 times 10 to the negative 20 joules. You have to write the unit of measurement. This is very likely the first time in your educational lives you don't have to have a unit of measurement, or you do. This is for all your whole life. You didn't. Now you do. And it is going to take some errors for you to get with the program. I will help you with that. Another thing is, I want you to take a look at the coefficient, this part, this number. Is that in proper scientific notation? No. I think Jad or one of you over here, we did this a few days ago. Your answer must be between 1 and 10. So we need to move the decimal 1 to the left. This would be 4.79 times 10 to the, where will it become negative 21 or negative 19? Negative 19. Garrett, this is the second time I've talked to you in 60 seconds. Wake up. And now that's on YouTube. That is your answer. That's E. Chem can be hard. B student in chem in high school. I know how I feel. So rule number one, pay attention in class. Rule number two, you've got to be able to read the problem and identify what your knowns are and what your unknowns are. And then solve it step by step. I showed my work. I want you guys to be able to show your work. So if you do make a mistake, I can tell you where you went wrong. You're going to make mistakes. I need you to live with that fact. You will make mistakes. Do you see people make mistakes in practice? What is practice meant to do? And learn from them, correct them. This is practice. I don't want you making those mistakes on the test. I don't want you making mistakes in the game. That's what practice is for. Fix them so you don't do them in the game. Okay? All right, let's move on to your next lesson because I want to be ready for Monday and Tuesday because Monday, Tuesday, and Wednesday, you guys have like a big deal lesson. I want to make sure we have all the time in the world for that. So this is going to be lesson 4.3. Quantum theory and the atom. I'm going to stop the video and then start it again for the next lesson.